Great. Hi, everyone. So I'm working for Quarkslab, which is a French security firm, and I'm doing obfuscating compilers there, which means I'm trying to make the job harder for reverse engineers. So I thought I would talk about this, and then after a glass of chartreuse and a talk yesterday, it turns out that it would be much more entertaining for you just seeing how our test suite just fuzzed some pieces of LLVM. So let's start. One thing we want to do is to replace every constant in your code by a computation that evaluates to this constant. And in your test suite, you do this for all the constants, and then you try to compile this with clang, the generated bytecode, and it just hangs, maybe in the register allocation steps. So you don't want to generate that strange code, but when you're obfuscating code, you're exploring all the area of the human brain. For example, during validation, we wanted to make sure there was no invalid memory access. So all the tests ran under Valgrind. And then you hit this assert, because Valgrind assumes that a function with more than, I can't remember the real number, more than 1 million of instructions doesn't exist. So it just stops. But we do generate this kind of thing for testing, not for the customers, but still. And there is a limit to LLVM too, because when you have the SD node at the end of the pipeline, you may end up generating nodes that have a lot of children. So many children that it overflows the short that is used to store the number of children. So you hit this and you wonder, what did I do wrong? And it's just that you're not supposed to do this kind of thing. And then you're obfuscating, so you don't want to do always the same thing. You want to be random. And so you grep for random in the LLVM source code, and you say this creates random generator in model. And in fact, there is a single place, because it's defined, but never used in any place of the LLVM code. And in fact, it's obvious, because this type random number generator is not even compatible with the standard distribution from C++11. So it exists. It's not tested at all in LLVM. I've checked the test. I don't know why. And then we have this function creation stuff that comes from the outliner part of the code. And you can see that they have a way to forge a new name, which is great. So we are outlining some random piece of code, and then you give this to the ARM assembler, and it chokes, because it turns out that there is a dash here, and a dash is not supposed to appear as a name of a function for the GNU assembler, for ARM, and we filled the bug request and it got fixed. But people don't name their function with a dash, but outliner does generate function with a dash. LLVM is generic. So let's take advantage of this and write some strange computation. So why not using this kind of integers? You can write it in LLVM, process it, everything works. And that's the perfect world. And then you meet reality. You try to generate x86 code, and you meet the assert. Because, well, it's kind of complicated to do this, right? Then you think, well, this Bitcast from integers to vector of integers just works. So let's explore how it works. This looks nice. In fact, it's a way to encode just an OR. And you pipe it, you give it to clang without SEC activated, and it recovers the OR. That's great. But it turns out that clang also has obfuscating possibilities, because if you activate SSE, the legalization turned out to generate this kind of thing, which is great because we don't have to build an obfuscator. It's built in clang. And finally, I just want to tell you the story of my life for the past 2 years. Building an obfuscator means exploring all the twisted parts of your mind. So you design a new obfuscation, and you think, well, they're really going to suffer with this one. You test it, it works great. Then you're saying, okay, I'll try to to test it a bit more. So you just get CMake, you compile the source code of CMake obfuscated, which is irrelevant, but it's a good test case because the validation suite of CMake is great. And then you run the test suite, and the validation fails. And it's quite complicated then to debug the obfuscated your generated out self. So the story here is a good one. It's, well, there is justice. They're going to suffer, but first I've suffered too. And that's all for the talk.